Howdy. Here's a quick one for you. I'm opening up my old project here. This is what I've got. And there was this little bit of a feature that I wanted to implement into my character movement that is known to exist in certain games like platformers and such, right? What is it? You saw it in the title of the video. It is that right there. You see that? Yeah, beautiful. Yep, we're looking at making a more kind of crispy jump through the default character movement component, right? Because there's like it can be floaty by default. Because I watched a video. There's a video about Mario. You know Mario, and the original Mario. How it takes twice as many frames to jump up as it does to come down. And I thought to myself, oh, that makes sense. It's a way to make your jumps feel a little bit more crispy. And so I figured out a way, and this works in networking using the character movement component, and you won't have any lag issues or anything like that. So that is cool. Let's get to showing how this works. Rightio. So the thing that you'll need to do is you'll need to create a C++ class that inherits from the character movement component. So I've got one here. Gone and created it. This is an old project, obviously, right? You inherit from it. Now, I have done a lot of things here. This just to get some networking stuff working, but it's not to be worried about because the only thing that matters to you is this right here, the getGravityZ function. So it's a function that you can actually override. So that is something that you will need to do. And then this one right here, right? Now it might not necessarily. Oh, I don't know. You can make a replicator. You can make it not. But the main thing is that it is a U-curve float, right? Because essentially the solution that I have come upon, right, is that there's a gravity scale by default as part of the character movement component. Familiar with this one, right? But that's just like a default number. And we don't necessarily want a default number because we want it to kind of change depending on whether you're going up or if you're going down, right? Which now, if we go to the implementation of this, right? So you'll need to implement this function. This is basically all it is. If we have a gravity scale curve, then we try to use it in our calculation. Now I do super here because if I call the parent class version, right, then I multiply by gravity scale, which I no longer want in this situation. You can keep it if you want, but I no longer want it, right? And in this situation, basically all that we're going to do is that curve that we've gone and declared, we're going to get a float value based on the z velocity. So whatever our z velocity is, and then multiply it by the gravity, which obviously, the movement component gets it from the physics volume that it currently exists in, or the just default gravity z, right? So that's how it does that. It updates it and stuff like that, and so we can use our gravity scale curve and multiply that by the z that it goes and finds, right? And essentially, all you have to do with this is create a blueprint, C++, whatever you want, a character. It eventually has to become a blueprint, right? You create a character that has that character movement component, so you will need C++. I've just been reminded of that. Yep. Right. So then you'll create a blueprint character, and you'll need to create a asset, right? So create yourself a gravity scale curve or whatever you want to call it. But essentially you have to think about it like this. This gravity scale curve takes in whatever the z velocity is and then outputs a scale based upon that, right? So you'll see here that at -1, we make the gravity scale 4. So it's an increased gravity scale. At positive 1, we make it a value of 3. So it decreases the amount of gravity that the player is affected by, or any character is affected by, based on what their z velocity is. So when they're falling, they'll fall faster. When they're going up, they'll go up slower. And then inside of that blueprint right here, you'll be able to put that into there. And then because of that simple C++ code, that is how you get that result. And you can mess with that as much as you want because it is a gravity scale curve. You don't have to follow the same logic as I do. You can mess around with this, add extra points, make it so it's more of an actual curve instead of a straight line. Whatever you kind of want to do, you can do that because it's all set up in that way. So yeah, if you enjoyed that video, if you found that helpful in any way, please leave a like and subscribe as more things get created. Cool. I'll catch you around.